Okay, good afternoon. Today, I hope to do two examples on relative motion analysis with velocity. Then if I could finish, we are going to look at instantaneous center. Okay, so I'm going to start this problem over again. Okay, just to quickly recall. So with the slider block A is moving downwards at VA is equal to 4 meters per second. Determine the velocity of the block at the instant shown. So the formula we're going to use in general, I like to break it down, the formula that we're going to use in general. So it's VA is equal to VB plus by omega AB cross. Now the R part you have to be careful, okay? So A is the point of interest, B is where you are taking your reference from. Okay, so just remember this formula for this. Okay, so let's look at this again. We know that block A is moving down in 4 meters per second. Okay, so what is very sure over here, you can write that VA is equal to minus 4J. The fact that it's coming down in Cartesian coordinates, J coming down is negatives. Okay, again, we have to sketch our transformation. Pardon me, yep, recording. This is X, this is Y, this is rotation of Z. Okay. So let's try to look at some simple stuff first, okay? So likewise, we're going to visualize how this structure will move, okay? So I want to highlight what you see over here, okay, that I'm highlighting now, which I did not explain properly. All these are known as what? Pin joints, yes or no? So all these are known as pin joints. So for pin joint in general, right, they can move in X and Y directions. Okay, can move in X and Y directions if it's a pin joint. What is interesting over here, I want to take your attention to B. Okay, at point B, we know, again, this is a velocity analysis. We know that VB can only move. Wait, come on. Move in X direction. Yes or no? So I want you to visualize, if A is coming down, what will happen to B? Is it going to move towards the left or towards the right? It's going to move towards your right, yes or no? Okay, so this is, you are comfortable in this, yes? Okay, so we know that over here, we have going to have a VB. Because it's on a slider, the slider is in the horizontal orientation, we also can claim that VB is equal to VBI. There's only one direction, and we're going to declare this is equal to positive. Okay. Then we are going to, from here, how is omega AB going to rotate? Right? So omega AB, if you visualize A coming down, omega AB has to rotate in this orientation. Yes or no? Right? So this is your omega AB. Okay. So we can state the fact that omega AB is also equal to omega AD, and is going to be what? Negative. Okay, because clockwise is what? Negative. Okay, and then immediately you can declare why this is a fact, because member ABD is what? Rigid body. So the question asks us to find what is VC. Okay. What is VC? Anyone want to guess the direction of VC? Yes. Towards the left. Yes or no? I don't know where it is also. Okay, I don't know. Okay, so I will tell you what we are sure. So this we are very sure. This we are also very what? Sure. Right? VC we don't know. It can either go left or right, but to be frank, I don't know. But we can go assume it's going towards what? Left. When it goes to the left, what will happen to the member CDE in terms of rotation? Clockwise, yes or no? So you're going to have a clockwise rotation. Okay, so this is your omega CD, and this is also assumed. It is okay to be to assume. Okay, don't think that assumption is wrong. Not necessary. Okay, some things you can be very sure. For this case, if you're not sure, you can make the assumption. Later on, I'll teach you how to flip the sign. Okay, so we are going to so we can write further that we know that VC is equal to negative VCI. Because VC is only one direction, yes or no? It can only move left and right. It cannot move what? Up and down. And the next thing that we can conclude is that omega CD is also equal to omega CE, and it's also going to be what? Negative. Negative claiming that it's going to go what? Clockwise. I put down here again, negative declaring that you can rotate clockwise. Okay, so these are the things that from a diagram like this, you have to, we have to analyze. Are we clear? Okay, write this down first, then you'll be fine. So the next thing we do is we are going to determine, you know what, I'd like to apologize about yesterday. I make this problem sound really, really confusing, but it's not. Okay, it's not that confusing. Yes. Yeah, both omega AB. Oh yeah, omega AB and omega AD. Thank you. One pint of beer. Thank you. Okay. Right. So this assumption we make about omega CD and omega CE is again member CDE is a what? Rigid body. Okay. So we are going to determine BC. Okay, we're going to determine BC. I'm going to copy the diagram. I'm going to paste down here so you can see. So you have to look at continuity. Okay, so you know that BC or the block C is related to what? D, yes or no? Right? So the first equation you write is VC is equal to VD plus by omega CD cross R C from point D. Okay. So I'm going to declare this as my equation number 1. So over here, we know that we have two unknowns. So you just write below unknowns. I mean, I will write this down. During the exam, you don't need because I'm teaching. The unknowns are VD and what? Omega CD. Right? You have two unknowns, you have one equation. We have to be really, really careful. I'm not saying it's not solvable, okay? But we don't have VD, okay? And by looking at VD, is spin, yes or no? So VD, okay, has two directions also. So VD, point D, has both I and J directions or velocities, right? Because it's up in free air, and we cannot assume that it's only one direction. We cannot do that. Are we clear? Okay, we cannot assume there's one that it has freedom to move left and right, up and down. Okay, yes, that freedom. So from here, we cannot do anything, but what do we have? We have something known as what? VA, yes or no? So we are now going to equate VD to VA. So I'm going to find VD is equal to VA plus by omega AD cross R D from point A. Okay, so this is our equation number 2. So from here, it's sometimes difficult to foresee what's next. Okay, so you realize that you cannot do anything else. So the best thing now is to put in the numbers. Are we clear? Okay, so we are going to look for VD. VA is equal to minus 4J. Remember, omega AD, we're going to assume it to what? Hey, no. This is we're going to assume omega AD to go in what direction? To be clockwise, so it's going to be what? Negative. Right? Clockwise over here means negative. So plus minus omega AD, okay, cross. So we need to find R. The reference point is from A, and then we need to find D. Okay, so it's 4/5 multiplied by 0.3. And I have to include a minus sign. Then let me write bigger. 1,000 apologies. Okay, so you have minus, okay, 4/5 multiplied by 0.3. Okay, and then this is your I, and then your J is positive because it's up 3/5 multiplied by 0.3, and this is J. Okay, so you write this out. VD is equal to minus 4J plus bracket minus omega ADK cross, and then now is 4/5 times 0.3, 4/5, 0.24, okay, 0.24 minus, sorry, minus 0.24 I plus 3/5 times 0.3, 0.18 J. Okay, then from here, you have VD is equal to minus 4J, right? K cross I is going to be what? K cross I is positive plus by 0.24 omega AD, and this will be J. And then K cross J is negative, negative, and negative will become positive, 0.18 omega ADI. Okay. As I mentioned before, right? So from here, when we got this equation over here, right? We know VD has two directions. Okay. So if we're going to write on VD, we have VD in the x direction I plus by VD in the y direction J, this will be equal to minus 4J